Hi, Neil. Thanks for taking the time to speak with us. I wonder if you could just tell us a little bit about what Aker Solutions actually does.
Yeah, sure, Keith. So Aker Solutions is a company that provides products and services to the global energy market. The part of the company that I'm involved in is the Subsea Controls division, where we're involved in subsea equipment and the related topside components for the control of that.
Fantastic. So you say subsea. I mean, does that mean that the equipment's actually on the seabed?
Yeah, so we supply a number of different pieces of equipment that get deployed subsea. You're talking about the subsea control module, which sits on top of a subsea Christmas tree. That's all tied back to the surface, where we've got equipment like a master control station, electrical power unit, and hydraulic power unit. And they all complement each other to become a subsea control system.
Wow. Now, a Christmas tree, that's not the sort of thing you'd put next to your fireplace in your house, right?
No, there's no tinsel or fairy lights on these trees. These are basically mechanical stacks with either vertical or horizontal valves. Sits on top of the subsea wellhead, and basically its purpose is to control the flow of hydrocarbons from the reservoir.
So where does VTScada fit in here? At what point are you using VTScada?
Yeah, we've been using VTScada and its previous incarnation, so VTS and Web, for many, many years. This is used in our master control station, which would typically sit in a control room environment on the offshore platform. We've got an application, an OEM layer of VTScada called SMAX. So we've got our own custom drivers for controlling our subsea control modules. We've got our own communication protocols written in VTScada script. We also use some of the built-in drivers of VTScada, such as the Allen Bradley SIP driver for communicating with a host of PLCs, etc.
Excellent. Now, I'm just going to interject for our viewers in North America. We'll jump between SCADA and SCADA. We actually call it VTScada over in Europe and UK, but in North America, it's VTScada. And because I speak to my colleagues all the time, I tend to use SCADA. Now, how do you communicate from the top side to the subsea control modules?
So just to give an overview of a typical Aker Solutions control system, this is the Total Dahlia project that we supplied a number of years ago. Our topside equipment is deployed on what's known as an FPSO in this case. That's a floating production storage and offloading vessel, as opposed to the traditional offshore fixed platform. What we can see happening here is the animation's taken us into the equipment room, and inside here we can see a number of bits and pieces of our equipment. What you see here is the SPCU. This is the Subsea Power and Communications Unit. In this case, it contains the electrical power units. These units typically take an input from the FPSO in the range of 220 to 240 volts or thereabouts. They would convert that to DC. They would rectify the signal, and then they would provide an adjustable output voltage in the range of 240 to around about 1000 volts AC. So it basically produces a clean supply for our subsea equipment. Behind the doors, you can't see these, but we would have a number of modems to communicate with the subsea equipment. So we're just given a bit of a tour of the equipment room here. And then here you can see outside the vessel, this is umbilical terminations. We would call this a TUTU, topside umbilical termination unit. This is where all the signal, all the power elements from the topside are combined into umbilical cores and basically routed to the subsea. What we see here is our subsea control module. These two canisters, this would contain the subsea electronics modules. We've got two in this case. It's a dual redundant control module. You've got a number of DCVs. It's quite hard to see in the background there, but that's what they are, directional control valves. These are the devices that they're electrically fired. So If an electrical pulse is sent to these, they will open up, and the result is that hydraulic energy is output from the control module, thereby operating a tree valve. Subsea, we're seeing the tree and an associated valve mounted on the tree. And what we're trying to do is send a signal from the top side on our control system to operate that valve on the tree. So a command is sent to open this particular valve. What's going to happen is the command will come out of the workstations, the operator workstations. It will enter the subsea control units. It goes into the SPCUs, the Subsea Power and Communications Unit, so it gets sent through the modems. Feeding into the umbilical, you've got signal, you've got power, and you've got the hydraulic power going in through the umbilicals to be fed subsea. Now, obviously, this process happens much faster than what we are seeing in this illustration here, but this is slowed down to give people an understanding of how the system works. So water depths in this case, we're told, is 1.3 kilometers. This is off the coast of Africa, so it's quite extensive water depth. So subsea, what we're seeing here is some form of subsea distribution unit. The signal enters this unit, and then it's sent out to the appropriate control module. So here we see the signal entering the control module of this particular tree that we wish to operate. What's happening is the signal from the modem makes its way into the subsea electronics module. The modem inside there decodes the signal. It fires a solenoid, which results in the directional control valve opening. When that opens, hydraulic fluid is released, and the result of which is that the production master valve of the tree is hydraulically latched open. And this results in the valve opening.
You mentioned hydraulic pressures there. What sort of hydraulic pressures are you talking about?
So the hydraulic power units on the surface, they will typically output on average for a high pressure supply, perhaps something as much as 500 bar, maybe 600 bar.
Wow.
So quite an extensive pressure, yeah. To put that in context, we're often having to deal with distances from the host platform of up to 100 miles in some extreme cases.
So the equipment's on the seabed. It's not like you can just swim down and push the reset button if something goes wrong. Do you have redundancy built in?
We do. We've got redundancy both subsea and topsides. So topsides is a lot more simpler. It's basically two industrial PCs within the master control station arranged on a hot standby basis. Our subsea control modules tend to have dual electronics, so it'll have a subsea electronics module A and B. So we retrieve values from both back to the master control station.
Okay, and what do you do with those values? I mean, do you display them both to the operator, or what do you do?
No, so built into our OEM layer, our SMAX product, we have got a number of arbitration policies to basically select the best quality information from SEM-A and SEM-B.
Fantastic. So you mentioned that you have the SMAX OEM layer. What other unique things do you have in there that would differentiate it from a standard VTScada application?
Well, I believe we're away to be doing a screen share soon, so you'll see right away that the operator interface looks quite different from out-of-the-box VTScada. So what you see in front of you is the SMAX application. What you see in the background with the communication messages going to and fro, that's our subsea simulation, which we call Mascot or ETU, to simulate the subsea control modules.
That looks like, do I recognize a little web icon on the taskbar there? Is that our
You do. So Mascot, the simulation unit, that is actually built on trihedral web dating all the way back to 1996, I believe. This is
wow.
an early version of Web 4, I believe it is, yeah.
So that overview screen there, it looks completely different to what we would class as standard VTScada application. Can you just give us a quick run through of some of the screens?
So yes, so at the top here, you've got an alarm banner. Now, it just so happens we don't have any alarms at this exact moment, but this, if we did, this is where they would appear. You've got the main operator screens further down that can display, here's our MCS status, and we've got hydraulic power unit status. We've got a typical well page with all the sensors and valves and chokes. On the right-hand side, you've got the usual customer logo, you've got some alarm control, and you've got some quick links to some other useful parts of the system, such as the tag browser. If you need to do some trending or look at the event log or the alarms, then you've got some quick links to them here. And at the very bottom, you've got the event log.
Okay, so the tag browser would just be the standard VTScada tag browser, for example?
Well, we have got the standard VTScada tag browser in the latest version of SMAX. Okay. But this is a previous version dating back a few years now. So this is SMAX version 6, and it has got its own customized tag browser.
Right. Right, very good. So I see a button there called sequences, just a hot link button called sequences. Is that the shutdown system? Is that correct?
It is. So most of these systems have got some form of shutdowns to be run. And that's basically an interface to the platform control system, which can decide, you know, we've got a bad situation occurring here. We need to instruct the subsea system to shut down. So the master control station will interface to the platform control system and react to, you know, any odd or unwanted occurrence. What would typically happen is, and I can simulate some of that just now, what you see here is a shutdown screen that basically shows a representation of the cause and the associated effect if such a cause should happen. We can create one of these causes right now by plugging a value into the mascot software. If I was to create a situation where we had a high pressure buildup.
It's a very high pressure.
In fact, I think, right, so what I've done is create a low pressure condition.
Okay.
So what you see here is the trip condition is represented here, and the necessary impact, the effect, is shown occurring here. You've got these X's that show these particular valves are going to close as a result of this shutdown.
Excellent.
Trip.
And I can see that in the event log there, as these valves are operating, the events are being logged in the bottom display there. Just explain.
Yes, everything is logged. So you get a quick view just by clicking here. This gives you the most recent events, but if you want a more extensive event log, you can click on the button here, which gives you the full traceability, you know, dating back hours, days, months, years, however long you want to go back.
Back on the, I think I noted on the MCS page that you had the master control station overview page. There.
Yes.
That showed the layout of your actual rack that's installed offshore. The key switch panel that's under the monitor there. Can you explain a little bit about what is that?
So this is our changeover system. We've got a key switch operation, which is used by the operators to select which IPC, which industrial PC is designated as being the online machine. So if for whatever reason, someone needs to perform a manual switchover, if they need to take the A machine down or whatever, then they can simply perform a key switch operation, promote the other machine to be the online machine, and then they can do maintenance work or whatever is required on the machine that's been taken out of service.
So this is real high availability, mission critical, I guess. Nothing, there won't be any oil or gas flowing off the platform if the system's not operating, is it?
Indeed, a lot depends on these systems. Yep.
Wow, that's incredibly interesting, Neil. So I take it you have quite a large install base of these SMAX systems?
Indeed, we do, and not just in the UK sector. We've got them on a global basis. We've been developing these SMAX systems now for some 25, 30 years. So yeah, the install base is quite extensive. I don't have an exact number, but it is probably in the realms of about 150 systems.
Wow. Wow, that must keep you really busy. Well, I really appreciate you taking time out of your busy schedule to show us the SMAC system. It's very interesting. Thanks for your time.
Thanks, Keith.